My name is AKASH and my teammate is LOKESH Kumar, and the title of our project is Sarcasm Detection Using Natural Language Processing, which we are doing for the course Natural Language Processing CAC 4022. So today's agenda is these 5 topics: introduction to the project, what's meant by sarcasm, and the models available for this sarcasm detection, dataset and methodology, conclusion, and I also have extra content along with it. So, introduction. Sarcasm detection is a very narrow research field in NLP, a specific case of sentiment analysis where instead of detecting a sentiment in the whole spectrum, the focus is only on sarcasm. Therefore, the task of this field is to detect if a given text is sarcastic or not. The first problem when we come across and detection of sarcasm is, unlike in sentiment analysis where the sentiment categories are very clearly defined, like love objectively has a positive sentiment and hate a negative sentiment. No matter who you ask or what language you speak, that doesn't change. But for the borders of sarcasm, those things aren't that well defined. And it is crucial that before starting to detect it, you have to have a notion of what sarcasm is, which we'll see about in the next slide. Before that, let me say why it is a very major problem in detecting sarcasm is, because even as humans, when you're trying to detect sarcasm from another human being, we have to make sure we see two important things: the facial features, like the kind of emotions they show when they're speaking this particular sentence of sarcasm, and also the tone in which they're speaking. But even then, we may be wrong in detecting sarcasm. So in case of a mission, it's going to be even more harder. So it's going to be a challenging task doing this. So what is sarcasm? According to the Oxford Dictionary, provides the following definition: sarcasm is the use of language that normally signifies the opposite in order to mock or convey contempt. So some people could disagree about its purpose, but there is a convention in that people use positive words in order to convey a negative message. Like in earlier days, sarcasm was not that common, and it was rarely used in case of internet and stuff. But now, since there are many casual tweets and stuff, the sarcasm has become increased in nature. So it's important to detect sarcasm, and of course, it varies through person to person and is highly dependent on the culture, gender, and many other aspects. Like for example, American and Indians, for example, perceive sarcasm differently, and moreover, someone being sarcastic doesn't mean the other perceiving it as a speaker intended, and it changes because there are two types of sarcasm. One is the intended sarcasm, which is done by the speaker, and another one is the perceived sarcasm, which we understand it as. So this subjective will have implication in the performance of the real models, since both are hard to differentiate. Okay. Now, why is sarcasm detection important and why we chose this specific topic? Like, you can see the tweet on the left. So you can see that it's kind of a racist tweet to do, but actually the user who wrote this tweet intended it to be sarcastic. So this tweet went viral in 2013. The woman who wrote the tweet before getting on a plane, and when she landed in the African country she was visiting, Twitter had exploded and she received many messages, and most of them are like uh, people accusing her of all sort of things. She even lost her job. When someone finally let her speak, she said that she was being sarcastic and joking and she didn't mean to offend anyone. But at that point, she already lost her job and everything, so her intentions was irrelevant. So to prevent incidents like this, it would be useful to build a model that can detect sarcasm, at least not precisely, at least approximately, to prevent incident like this from happening. So what are the models that are already available? on this field. Like there's a myriad of DL models and combination of architectures to implement sarcasm reduction. Like up until 2017, most models were machine learning models, logistic regression, SVM, and some attempts with CNNs. Around 2017, LSTM started to have traction, and because of their sequential nature and easier handling of long-range redundancies, they took over the ML models. But attention models such as transformers quickly replaced these two, and nowadays a combination of both the transformers, dense networks, and also share of layers are being used in sarcasm detection. So now let's talk about the dataset that we are going to use and the methodology in which we are going to achieve creating this model. So we are going to actually use two dataset. The first dataset is something called as master dataset, which we took from GitHub. This dataset, the full form is multimodal video corpus for research in automated sarcasm discovery. This dataset is compiled from popular TV shows which has sarcasm, including Friends, The Golden Girls, The Big Bang Theory, etc. And mustard consists of audio-visual utterances annotated with sarcasm labels, so that now in finding sarcasm is not only limited to textual data but also audio and video files, and each of these utterances is accompanied by its context, like the previous lines that people spoke and particular situation in which it happens. So that provides additional information on the scenario and where the utterance occurs. For example, we can see uh, one of the data given on the right, and we can obviously perceive sarcasm in that. So this was a very helpful data set which we could get our hands into. So the second data set is we we got from web crawling in Twitter. Twitter provides functionality to users to summarize their intention via hashtags, like using user self-declaration of sarcasm as a retrieval cue. Like if you tweet something sarcastic and if you want the audience to know that it's sarcasm, you can use the hashtag like sarcasm, so that to avoid the incident like we talk about later. And so we have crawled the Twitter sphere to find like those tweets which has the hashtag sarcasm in it. And since this simple heuristic misses those uses of sarcasm that lack this hashtag, we use the LSA based approach to extend the list of indicative hashtags, like to include sarcastic and also like yeah right, like those hashtags are usually related with sarcastic tweets, so we took those tweets too. So we also harvested tweets from user profiles with a strong bias towards sincerity or for professional wit sarcasm. To build our sarcastic data set, we aggregated all these tweets containing one or more positive markers of sarcasm, but also removed such markers from the tweets, while tweets which did not contain any positive markers of sarcasm were considered non-sarcastic, even if they are sarcastic, because it is kind of impossible to find it's just a blunt statement sarcastic or not without any indicators. So our methodology is we're going to use neural networks for this, and there are different type of neural networks, and let's see about that and which we are going to use. Semantic modeling of sentences meaning using neural networks, and this has been a target of attention in the social media community. Neural network architectures such as CNN, DNN, RNN, and also recursive neural networks have shown excellent capabilities for modeling complex word composition in sentence. Yeah, sarcastic text can be considered elementally as a sequence of text signals or word combination. RNN is a perfect fit for modeling temporal text signals, as it includes a temporal memory component, which allows the model to store temporal contextual information directly into the model. So, the RNN seems like a nice idea. CNN was also a model which is important, which we will talk about later. Now, the RNN can also aggregate the entire sequences into a temporal context that is free of explicit size constraints. Among the many implementation of ornaments, LSTMs are easy to train and do not suffer from vanishing or exploding gradients, while the sentence modeling with CNN information back propagation through time. LSTM has the capability to remember the long distance temporal dependencies. So LSTM also seems like a nice option, but moreover, as they performs temporal text modeling over input features, higher level modeling can distinguish factors of linguistic variation within the input. And the another advantage of CNN using CNN is that it can also capture temporal text sequence through convolution filters. So, what is the current stand on this topic? Sarcasm reduction in natural language processing. So, how much it is prominent right now? Like currently, people are using mostly text data from Twitter and Reddit generally, but also from other discussion forum posts where sarcasm is common. And as for the features, they use some lexical features, contextual embedding for words like BERT and user embeddings. Every month, there are new published models, usually a combination of transformers with some dense layers, as we spoke about earlier. Okay. So some errors that are common nowadays is false negatives, like sarcastic tweets not being detected by the model, most probably because they are very specific to a certain situation or culture, and they require a high level of knowledge that DL models don't have. Like I don't think many humans don't have that knowledge about a particular culture to understand the sarcasm. Uh, the most effective sarcasm is the one tailored specifically to a person, situation, and the relationship between the speakers. Sarcastic tweets written in a very polite way or undetected. Sometimes people use politeness as a way of being sarcastic, like highly formal words that don't match the casual conversation. Complimenting someone in a very formal way is a common way of being sarcastic, but though we can understand the sarcasm, a machine learning model won't. So that's a problem we have to face. So that's it for now. Thank you. So now that the PPT is over, let me show you the some of the research papers that we referenced for this project. So this is the first research paper which also uses neural network to find sarcasm. Uh, so the abstract of this research paper is like to find the precise semantic representation of a sentence and definitive information extractions are key steps in accurate processing of sentence meaning. So especially for a figurative phenomenon such as sarcasm, irony, and even metaphor, cause literal meanings to be discounted and secondary or extended meanings to be intentionally profiled. So like sarcasm, irony, and metaphors, all three of these things are difficult to find in English language because often their use will only be known if you see the facial expressions of a person while they're speaking it. So just on text, it's really a problem to find these things, but neural networks is really going to help us in finding and making a approximate model for sarcasm detection. So the semantic modeling faces a new challenge in social media nowadays because grammatical inaccuracy is commonplace, yet many previous state-of-the-art methods exploit grammatical structure. So if a person writes in an informal manner instead of using correct grammar, like nowadays everyone has cell phones, so if they're making a casual conversation, they don't actually worry about grammar. So if a tweet is not grammatically correct, it's difficult to exploit the grammatical structure and find sarcasm or irony or whatever you need to find. So that's a main problem nowadays. And for sarcasm detection or social media content, researchers so far have counted on bag of words, which means like finding the frequency of each word given in a particular document, and n-grams method like that, etc. And in this paper, they proposed around a neural network semantic model for the task of sarcasm detection. And they also reviewed semantic modeling using support vector mechanism (SVM) model, which I'll show you later. And this employs constituency paused trees fed and labeled with syntactic and semantic information. And in the end, they also proposed a neural network model composed of CNN, convolution neural network, and followed by long short term memory LSTM network, in which we are also going to work on. We are going to concentrate on mainly the LSTM and CNN. And but they also used a deep neural network, which this all are a part of. And this proposed model outperforms state-of-art text-based methods for sarcasm reduction, yielding an F-score of 0.92. So this is the most approximate sarcasm reduction model that we found with from all other papers. So maybe we will try to beat this F-score, but it will be seen in the end of the review 3, I guess. So yeah, this is the abstract of this paper, and this paper uses data set from Twitter and Reddit too. And then yeah, like they use recursive SVM for data processing. Then they use neural networks like CNN, DNN, RNN, and also recursive neural networks. And so yeah, this is one of the paper that we referenced for this particular project. And the second paper is this, and this is a paper in which we got an idea to incorporate multimodal sarcasm detection. So instead of only analyzing the sarcasm in text-based data, we thought of maybe there's a probability to analyzing audio files or video files by taking the subtitles and the context behind each scene. It would be even more addition to this sarcasm reduction model. So they also gave a very good data set in which they compiled uh, data from sarcastic shows like Friends, Big Bang Theory, etc. Like you can see one of these thing in which a person called Joey says, "Did you call the cops?" And Rachel replaces, "No, we took her to lunch." So this is the context of what's happening, and the sarcastic utterance here is said by the person called Chandler. He said, "Your own brand of vigilante justice." So as you can see, this is sarcasm, and such data is compiled and stored in a data set, which we are also going to use. And I think yeah, also many video files are manually uh, like anointed to sarcasm or not by various persons, which is also provides very helpful for us. So they are also saying the annotation process in which they told a particular video or text is sarcasm or not, in which they're saying that they built a web-based annotation interface that shows each video along with transcript and request annotations for sarcasm. And they also took the annotators to flag misaligned videos, cases where the audio or video is not properly synchronized. Then such files are useless, so they just cast it out. And the interface allows the annotators to watch a context video consistently of the previous video utterances whenever they want it necessary. For example, they're seeing a particular line and they can't say whether it's sarcasm or not properly. They can also view the previous context of the video to confirm whether it's sarcasm or not. And given the large number of videos to be annotated, they request annotations in batches of 4 videos at a time. I think it is given to different peoples by dividing into 4, because the amount of videos are large in these series. Uh, so yeah, this is the data set, second data set that we are going to use, and the first data set is the Twitter and Reddit textual data. So these are the main 2 research papers that we referenced for our project. So hope you like it. Thank you.